Good morning, everybody, and welcome back. Hope you're doing well, enjoying the lovely weather and getting outside as much as possible to recharge your batteries and have a break from being stuck indoors. All right, today we are moving on to different ways of calculating or expressing the concentration of a solution. And in your notes, so the title is Expressing Concentration. That's the 2 pages we're working on today. You will need your calculator, you need your periodic table. Today is all about math and unit analysis. So all our mathies out there, you're going to love today's lesson. Lots of canceling of units and using patterns to solve problems. So you have this in your notes. The concentration is quantity of solute over quantity of solution. In Chem 20, the most common unit we use is moles per liter. Sometimes you'll see it written as a capital M, which also means moles per liter, or molarity. That's one of the ways that we express concentration. This chart gives you some common concentrations of some different common substances. Most of them are acids. So vinegar or acetic acid, its common concentration is 17.4 moles per liter, or when you buy it in the store, it's 99.5% pure. And ammonia, household ammonia, which is a strong cleaner, comes in a very concentrated 14.8 moles per liter, which is 29% ammonia dissolved in water. Carbonic acid, there's a very low concentration. That's the acid that's found in pop. It's a weak acid. Trying to think of another name where you've seen it before. I'm not sure you have. So I wanted to compare these numbers, 17.4 moles per liter to 0.039 moles per liter. Using some vocabulary, we could say that the acetic acid is concentrated. Actually, yeah, I'll write it out. Acetic acid is concentrated at 17.8 capital M moles per liter, and the carbonic acid is dilute, H2CO3, at 0.039 moles per liter, capital M. So this is comparing dilute to concentrated. In picture form, you can see that dilute has very few molecules dissolved per liter compared to concentrated, which has, oh, what a mess, lots of moles dissolved per liter. You can try this at home. Get a glass of water and put 1 teaspoon of sugar in it, stir it in, have a sip. That's dilute. Then put 8 more teaspoons of sugar in, stir, and then drink. That's concentrated. Or you can do it with lemon juice. Put a few drops in, take a taste, and then put a couple big squirts in and take a taste to compare concentrated to dilute. And you'll figure it out pretty quick. Okay. I'm going to put a link to this after Crash Course in Chemistry for solutions. It's quite good, and that's nice to do, not must do, but if you want to watch that video, it'll help you out as well. Okay, as I've said before in chemistry, often you have to remember things and then be able to apply them. So today you're going to be given a bunch of different ways of writing out concentrations of solutions, and 5 in fact. So you're going to have to remember them all. And there's kind of a pattern. It's kind of easy to figure it out rather than just trying to memorize it, but you still will need to remember a little bit. So the first one is called percent by volume. So what that means is a volume divided by a volume times 100%. And the units that we use for volume are milliliter. So milliliters divided by milliliters times 100%. The second one, so that's percent by volume. The second one is percent mass by volume. So the unit that we use for mass is grams. Volume is milliliters. So grams per mil times 100% to get it into percentage. And then the last one is percent by mass. So just straight mass. So this is going to be grams divided by grams times 100%. So when you times all these by 100%, they become per 100 mil, per 100 mil, per 100 grams. That's what the percentage does. It gives you parts out of 100. The last two are parts per million. Sometimes you'll see it written as ppm. And to calculate parts per million, the units are milligrams per kilogram if it's a solid, or milligrams per liter if it is a solution. So usually dissolved in water, but not always for the solution. So milligrams per kilogram or milligrams per liter, and 1 liter of water has a mass of 1 kilogram, and that's why those two units are interchangeable, a kilogram and a liter. Kilogram equals liter for water. And the last one, the one we use the most in Chem 20, is the amount concentration. And in Chem 20, the word amount means mole. So the unit is moles per liter. And as it says here, this is the most common unit concentration in Chem 20 is moles per liter. So today we learn all 5, but for the remainder of the chapter, we are mostly using moles per liter. Okay, so we got all 5 of those. They're also summarized in your notes for you. Now we jump into the math. So here we go. A little bit of a change up for you. Okay, so to do these, you're going to see you have to remember the units, and then you have to solve by units. Okay, so what have we got here? 14 grams of sodium chloride dissolved in 112 mils of water. Find the percent weight by volume. Percent weight by volume. So the units I'm looking for, weight is grams and volume is mil. So I'm looking for grams per mil times 100%. So substitute into that. Here's my grams. 14.0 grams divided by 112.0 milliliters. So that's grams per mil. Now let's turn it into percentage times 100%. And you get 12.5% weight by volume. 3 sig digs, because both those numbers have, well, top one has 3, bottom one has 4. The 100% doesn't count. It's not a measured value. So 3 sig digs. Okay, what do you think? Oh, what the heck? That's supposed to be my smiley face. Now he's got a weird nose. I'll put another eye up there. Okay, moving on. Okay, flobberworm mucus is used to thicken potions. Of course, you all knew that. A potion contains 140 milliliters of flobberworm mucus. Okay, 140 ml of flobberworm mucus dissolved in a 500 milliliter flask of the potion. Find the percentage, volume, concentration. So percent V over V, volume over volume, which is going to be milliliters over milliliters. Okay, so percent by volume. Millis, and it's always, everything's always less than 100%. So you're always putting the smaller one on top, or the solute. 140 milliliters of flobberworm mucus dissolved in a 500 ml flask of solution. Now we want percentage times 100%. Okay, so that works out to be exactly 28.0% volume by volume, and 3 sig digs. 3 sig digs, 3 sig digs. So we're good. Okay. Hopefully you're thinking, hey, these aren't too bad. Of course not. They do get a little more tricky, but basic idea is the same. Okay, Marvolo-Gaunt's ring. Marvolo-Gaunt's ring has a mass. Do you know the story of Marvolo-Gaunt's ring? It's one of these 7 Horcruxes, each one containing a small part of he who shall not be named's soul. What do they call that again? When you put a small piece of your soul into those to give you immortality. Oh, I've forgotten the term. I know you're all thinking, you're yelling at me. It's this, Mr. Johnson. Okay, so anyway, Marvell-Logance ring has a mass of 12 grams and contains 11.1 grams of pure Gobelin gold, the best gold. What is the percentage weight by weight? Okay, so units for weight is grams over grams. Whoops. Percentage weight by weight. So we need grams over grams times 100%. So grams, it's always a smaller number on top, so we have less than 100%. So 11.1 grams of pure Gobelin gold in a 12.0 gram ring. We need it as a percentage, so times 100% equals 92.5 even percent. Okay, so 92.5% pure Gobelin gold in that lovely ring. Okay, everybody remember where the ring was found, who found it, and what happened to them when they tried to destroy it? Think. If you haven't read the books yet or watched the movies, dig into them, not too late. Okay, 250 gram box of table salt contains 1.5% weight by weight of sodium iodide. So what does that mean? 1.5% is 1.5 out of 100 weight by weight, grams per gram. Okay, so what have we got here of sodium iodide? So that means 1.5 grams of sodium iodide in a 100 gram box. 1.5 grams of sodium iodide in a 100 gram box. So I guess the rest of the box is table salt. Okay. Find the mass of sodium iodide and sodium chloride. So let's do sodium iodide first. Okay, so the way to do this is we're looking for mass of NaI. So let's start with that. Here it is right there, grams of NaI. So in unit analysis, you always put the unit you're looking for first on top, 1.5 grams of NaI. Now, it just can't magically appear on its own. It's in a 100 gram box. Okay, unit analysis. We want to be able to cancel out the one on the bottom so that we just have grams of NaI. How would I do that? I'm going to times it by the grams that are of the box. There it is, 250 gram box, 250.0 gram box. And now you'll notice that the grams of box cancel out. So our final units are grams of NaI. So it's 1.5 times 250 divided by 100. And when you plug all that into your calculator, you get, where's my work? 3.75 grams of NaI. Now, sig digs, this is only 2. So my final answer needs to be 3.8 grams. Okay, second part of the question is what is the mass of NaCl? So in the box, so we know we had 250 gram box. And in that box, it's made up of NaCl and NaI. So I can subtract my original mass of NaI before I rounded it from the 250 grams, and that'll give me the mass left in the box, and all of that mass is NaCl. So when you subtract that, you get 246.25 grams. And we are going with, this is addition subtraction rule now. So 1 decimal place, 2 decimal places. My final answer is 1 decimal place, 246.3 grams. That says 3 grams for the mass of NaCl. Whew, how are you doing? So we're through the front page. Still got a bunch more of these to do, but they're all pretty straightforward once you get the idea of patterns and solving for units. Okay, let's take a look. Onward we go. Suppose you drink 175 milliliters of Polyjuice Potion, which I'll call PJ for short. What does Polyjuice Potion do? Why would you drink it? Think about that one. Ever wanted to be somebody famous? Here's your chance. Okay. So Polyjuice Potion is 12% weight by volume. So that means 12. So weight is grams, volume is mil, and it's a percent. So per 100 mil. Okay, of glucose. So 12 grams per 100 mil of glucose. I'm just going to write that down. Sorry. That is 12 grams of glucose per 100 mil. 12 grams of glucose dissolved in 100 mils of Polyjuice Potion. Okay, so the question is asking us, what mass of glucose have you consumed? Mass of glucose is what we're looking for. Okay, and we actually have it right here. There's our mass of glucose. So I'm going to start with that on top. 12 grams of glucose in every 100 mils of Polyjuice Potion. I don't know why it keeps making those into T's. So we just have to get rid of the milliliters of Polyjuice. And here's how we get rid of it. We have 175 milliliters of Polyjuice. So if I put this one on top, the milliliters of Polyjuice cancel out. I'm left with grams of glucose on top, which is what I want. So the math is 12 times 175 divided by 100. And when you put all that in, you get 21.00 grams of glucose. And sig digs, 2 sig digs. 21 grams of glucose. All right, so I am going to get you to try this one on your own. Pause the video and see if you can figure out the volume of Polyjuice Potion on your own, and then come back and see if you got it right. Okay, so volume of Polyjuice. So I know that I have 12 grams of glucose in every 100 milliliters of Polyjuice. That's what that is telling me. So I am looking for the volume of Polyjuice. This one, that's what I'm looking for. So I got to put that on top. 100 milliliters of Polyjuice Potion contains 12 grams of glucose. Now I'm looking for milliliters of Polyjuice. I need to get rid of grams of glucose, and there's how I do it. It says that they are allowed 9 grams of glucose in their daily diet. Drinking, this is muggles, of course. Wizards can have an unlimited amount of sugar. You all know that from watching Harry and Ron on the train ride to Hogwarts every year, chowing down on every magical sweet known to the wizarding world. Okay, so grams of glucose cancel out. 100 times 9 divided by 12, and then there's our final units, milliliters of Polyjuice. Plug all that into your calculator, and you get 75 milliliters, even 2 sig digs. 75 milliliters. I'm getting messier as we go on this. I got to get this pen figured out. I think I'm rushing too much. All right, so there we go. So far, so good. So now we're going to switch to parts per million. So we're done percent by weight, percent by volume, percent weight by volume. Now we're looking at parts per million. And again, this is the thing you have to memorize. Milligrams per kilogram. My gosh, milligrams per kilogram. I wonder if there's too many things running on my Chromebook, and that's why my pen is so slow. milligrams per kilogram or milligrams per liter. Both of those work for parts per million. All right, so what is the concentration of the Scelligro solution? Oh, so we better read the whole thing. 3.7 milligrams of scarab beetles is dissolved into 250 mils of water to make Scelligro potion. So you all know what Scelligro is for. Pretty handy stuff if you have a bad fall. So what is the concentration of Scelligro in parts per million? So it's either milligrams per kilogram or milligrams per liter. So when I look at the question, they're giving me milligrams and liters. So that's what we will solve for, milligrams per liter. So this one's super easy. Just put in the units where you need them. 3.7 milligrams over 250 liters. Now I've got my units where I want them. 3.7 divided by 250 works out to be 0.0148. Milligrams per liter. And we are allowed 2 sig digs. I keep doing Q's, 0.015. If you like scientific notation, 1.5 times 10 to the minus 2. Minus because it's a small number. Bet you don't need to use scientific notation. Okay, moving on. Got about 7 more minutes, I bet, to get these done. A sample of well water contains 0.24 parts per million. And I'm looking ahead and I'm seeing liters here, so I know it's going to be milligrams per liter. Iron 3 sulfate. So I'm just going to throw in right now the formula for iron 3 sulfate. So that's 3 plus and SO4 is a 2 minus. So I will need 2 of those for every 3 of those to balance it. Okay, so what are we looking for? Sample of well water contains 0.24 milligrams per liter of iron 2 sulfate dissolved from the surrounding rocks. What mass of iron 3 sulfate is present in 1.2 liters? So we are looking for grams of Fe2SO4 3, or mass. Let's maybe change that to mass. And then the unit we're looking for is grams. So I'm looking for grams or milligrams, so that's what I'm going to put on top. 0.24 milligrams per liter. Now I just want the milligrams, so we just have to get rid of the liters, and there's how we do it. And we put it on top so that the liters cancel out. And we are left with milligrams. So 0.24 times 1.2 is 0.288 milligrams. And I'm only allowed 2 sig digs, so that's where the 0.29 comes in. Okay, take a breath. One small thing left to do. My favorite one, amount concentration, the one we use all the time in Chem 20 and Chem 30. So amount concentration, and again, you have to remember this, moles per liter. Sometimes you'll see it written as a capital M. Amount concentration. So amount means moles. Concentration means solute in solvent, or moles per liter. So you just have to remember that. You'll see it written sometimes as square brackets for concentration or a capital C. So I'll use both of those. Let's take a look at an example here. What chemical amount of ammonia is present in a 2.5 liter bottle when you have that concentration? What chemical amount? Okay, so we are looking for moles. That's what chemical amount means. Hopefully you remember the symbol for moles, N. N equals moles. So when I solve this, I'm looking for moles. So that's where I start, right there. 14. Oh my gosh, painful. 14.8 moles per liter is the concentration of ammonia, and I just want moles. I have to get rid of liters. So where do I put liters? On top. Liters cancel out. We get our final answer, and that is 37 even. Okay. 2 sig digs. Okay, almost done. Take a breath. So these last ones, oh yeah, we got 1, 2, 3, 4 left. Okay. Oh my gosh. That timer means we're supposed to be starting a Google Meet pretty quick. So I'm going to pause here and come back to this.